2.1, operations with numbers. First thing we're going to talk about are the different types or the different sets of numbers. The most basic type of numbers are my natural numbers. Another name for my natural numbers are called my counting numbers. Right, 1, 2, 3, 4, 5, 6. We start at 1 and move on. The counting numbers or their natural numbers are n equals. What are my whole numbers? What's the difference between my whole numbers and my counting numbers?
Negative.
Nope, whole numbers are not negatives.
They're all positive.
There's no decimals in the counting numbers either. What's going to be the difference between the natural numbers and the whole numbers? What's missing? 0 is missing from the whole numbers. When we count, we do not count 0, 1, 2, 3, 4. Integers. What are the integers? Those are all my positive and negative whole numbers. So far, we have our natural numbers, our whole numbers, and our integers. Now, all of these numbers here are all part of what's called rational numbers. All of these rational numbers, these are numbers that can be written as a fraction. Rational numbers are numbers that can be written as a fraction. Irrational numbers are numbers that cannot be written as a fraction. What's the most famous irrational number? Pi. Pi is an irrational number. It's 3.14, so on, so on, so on. The closest representation of that is 22/7, and it's still not even perfect. All of these are considered my real numbers. These are all real, and then there's one little tiny category over here that's called the imaginary numbers we'll talk about later. Now, we're going to be dealing with these statements, and we're going to say that for all real numbers, A, B, and C, the closure property, A plus B is a real number. AB is a real number. What does AB mean? A times B. The identity property. What does identity mean? When we're talking about identity, what are we talking about? It's who you are. Well, if we're talking about math, it's the same exact number. So A plus 0 is A. For multiplication, what times a number in multiplication will get me the same number? 1. A times 1 is A. What does the commutative property sound like? Community. What do you know about a community? It's where you live. If we think of it this way, A plus B equals B plus A. What's the only thing I've done? Switched it around. If I live in a community and I move houses, am I still in that community? I just switched houses around, right? And then I have AB equals BA. 3 times 5 is the same thing as 5 times 3. 3 plus 5 is 8, and 5 plus 3 is 8. Addition and multiplication are commutative. Is subtraction commutative? What's 5 minus 3? 2. What's 3 minus 5? Negative 2. It's not commutative. The only ones that are commutative are addition and multiplication. Associative property. Associative property. What's associative sound like? Associate. What does associate mean? Who you talk to. It associates who you talk to. So A plus B plus C, A and B in parentheses, equals A plus B plus C. I have changed who you're talking with. Here I'll use 3, 4, and 5. What's 3 plus 4? 7. What's 7 plus 5? 12. So this side's 12. Okay, 3, 4, 5. What's 4 plus 5? 9. What's 3 plus 9? 12. Changing who you're talking with does not change the problem. All you're really doing is picking up the parentheses and moving them. Again, this only works for addition and multiplication. I use the same numbers. 3 times 4 times 5. What's 3 times 4? 12. What's 12 times 5? 60. Over here I have 3 times 4 times 5. What's 4 times 5? 20, and 20 times 3 is 60. Which one was easier to do mathematically? Which one, though? The left or the right? The one on the right probably is easier. 3 times 20 compared to 12 times 5. Why is the 3 times 20 easier to deal with? 20 has a 0. It's easy to multiply with zeros on the ends. The whole idea of knowing these properties are changing problems around to make math easier for yourself. Distributive property. You already know this property. We know how to distribute. A times the quantity of B plus C. All that means is A times B plus A times C. And the same thing works if there's subtraction in the middle. Inverse property. What's an inverse? It's the opposite. So, if we're talking about addition, what's the opposite of A? Negative A. If I'm talking about addition, A plus negative A will get me 0. For multiplication, what's the inverse of A? What's the inverse of A? Nope, negative A is for addition. Not negative 1 over A, just 1 over A. The inverse of A in multiplication is 1 over A. Order of operations. If order of operations has 4 steps. Yes, you guys know the shortcut to remembering these. That's right. Please excuse my dear Aunt Steve. All right, Steve. Order of operations. Hasn't had the operation yet. P stands for parentheses. Now, parentheses don't always have to look like this. They also look like this. They look like brackets. They can also look like that. These are all parentheses. The reason why you might see it like this is so you don't see this. This can be very confusing to see the same parenthesis over and over again. It's easy to lose numbers. That's why sometimes you see different ones. E stands for exponents. Exponents are one of the easiest mistakes to make. What's 5 squared? Why 25? 5 times 5. It is this number times itself this many times. It does not mean 5 times 2. I know everyone in here will make this mistake once this year and accidentally write 10. You've got to be careful. It is not 5 times 2. It means 5 times itself that many times. Now, M stands for multiply, and D stands for divide. Why are they on the same line? They're the same things. Multiplying and dividing are interchangeable. Dividing is just the opposite of multiplying. I can change any multiplication problem into a division problem just by changing the wording, just by rearranging. And A and S stands for adding and subtracting. You've seen this for every single year, but yet I will still see people give me this answer wrong. What's 10 divided by 2 times 5? It is not 1. It is 25. Why? 10 divided by 2 is 5, and 5 times 5 is 25. You have to move from left to right, whichever one comes first. Just because you see multiplying over here doesn't mean you do multiplying, then do dividing. This answer is 25, not 10. Or sorry, not 1. That's a time symbol, not a decimal. Any questions? Open your books to page 90 then.